Dear all, welcome to this new video where I would like to demonstrate the use of RoboDK software in controlling an Arduino built servo positioner. So the first step is creating a simple mechanism in RoboDK environment. You need to have the CAD files ideally in a step format to create a simple mechanism. I have already my CAD files ready, so I'm going to create a new station, which I already done it. And now I'm going to import this CAD files. So I do have two CAD files, which is one is the base of the servo positioner and another is the faceplate, which is moving part. So I'm importing the base part first. So why we need to have two parts is that because the one part is the base and the second part is the moving part, you need to configure as a second joint or as a link. So it is very important that you need to have this as two parts. So we have the first part ready. So the first part has come in. So you would have noticed this has come in a 90-degree reoriented position. So we have to bring it back to a neutral position in RoboDK. So I have the servo positioner here. So double click on the servo positioner. You can see the colors is also not good. The first thing I'm going to do is click on the more options and going to change the colors. So you can see here there are a lot of grayscales added here. So I'm just right clicking this and deleting this mesh. So you have all other three colors, which is what I need. Now the next thing is I'm going to reorient. So you can see here this is the Z axis, but it's oriented 90-degree on x-axis. So I'm going to reorient it back in the x-axis. So make sure that you use the move geometry option. So yes, I have it reoriented into position. And one more thing you should always notice is that when you are designing such a mechanism, it is ideal to bring the origin point at the point where you need to have a link, or you need to have a next member connected, or the next members where the first member and the second member are joining each other, where is the origin point of your motion to. So what I'm going to do is I'm just going to move my origin point accordingly. So you can use again the move scale option. So you can see here I want to bring it exactly at the same point, which is the axis of my servo motor. So I'm just bringing it, yeah, that's two axes are good. Now I'm just lifting it in the Z axis. So if you want to reduce the size of the your origin points, you can use the plus and minus. So I'm just trying to reduce it. Yeah, which is good. And now I have it exactly in the center of my servo positioner. You can toggle the views and make sure that this is in the center point. Yes, it looks good for me. Yeah, it's slightly offset, but I think it's good. Yeah, it's almost good. Yeah. So I'm keeping it in this position, and yeah, that's what my position is. And now I'm going to import my second part, which is my faceplate, so which is the moving member. So I brought it back into the work cell, and you can see it's in a different orientation too. So I'm just closing the first fellow, just opening up the faceplate, again going to options. I'm just changing the colors of the gray. I'm clicking here, so it has only the gray here, so I'm just double clicking on that, just making it to the blue color, because that's what my actual object which I printed, so it looks same. So just change the colors. Now if you notice, this has to be also changed on the x-axis 90 degrees. So just keeping it in the x-axis 90 degree. Yeah, that's what my actual object is. Now I have to align it with the origin point here, or the meshing point. So I'm just using the move geometry and just keeping it into the position. Yeah, the 10 looks good. And now in the z-axis, just coming down a bit. Yeah, perfect. So you can see here now it has meshed well. And also I would like to treat this as my 0 point on my actual object or actual servo position, which I had physically made. I made the 0 over this position, so I had to just bring back this guy. So in the z-axis is 180 degrees. Yeah, So that's where I'm bringing it back. But once you move that, you can see your point has slightly changed. So what you do is you just bring it back to the position. Yeah, which is -10. Looks good for me. Yeah, yeah. Other axis, everything looks good. Okay. So you can of course look from the top view and check if they are meshing each other. No, they aren't meshing each other. So you can see there is a slight variation here. So what I suggest you to do is just play around the values. Yeah, I think that's just a view, but it looks good for me. So, but in case if you haven't aligned it properly, you can make sure that you play with the X, Y, Z values and align it to the position. So you can see here now, this is my 0 point is towards the downhill. Okay, so that's the same way I'm going to show you the actual hardware a little later, but that's how my actual hardware is also aligned. So I've done that. Now the next step is to create a mechanism. To do that, you go to the utilities, you go to a model, a mechanism, and once you have the model and mechanism, you can give your a name of the mechanism. So my mechanism's name is servo robot, servo axis. Let's name as servo axis. So let's name as servo positioner. So positioner. Okay, that's my name, and my base is the servo positioner base, and my joint is the servo faceplate. Now, in my case, the servo motor I'm using is a simple servo motor, which is a 5 to 7 volt, and this is a high-speed version from Beta. And I will put the part numbers and other things in the description. So I have the move range from 0 to 180 degree because it's a 180 degree movement type servo. And I've noticed that I need to invert this. So you can always check the direction of servo, but when I check the direction of the servo, this has to be inverted. So I'm just clicking on the inverter so that both of them move in the same direction. You can always check this physically on your motor and your CAD, and you can either change in the CAD or you can also change in the motor. So I'm just inverting it and giving OK. So now you can see here I have got my mechanism created here. So the first thing is once you have the mechanism ready, so I'm just closing the other menu so you can have the mechanism here. In case you don't get this, how do you get this is double click on the mechanism. So that's the base frame. So you have to click on the mechanism, servo positioner. So once you have that, you have here. So you can jog the axis here. So jog and see, yes, it's moving really good. Yeah, you can see here, this is the same thing what I have in my hardware also. And you notice this direction of motion. This is exactly same as my direction of motion on the actual hardware. In case you feel this is different, you can delete this thing you have created and play with the inverted options, whether to enable or disable and bring them to the same direction on both software and hardware. So that's the first step where you create actual hardware. You can see all the axes are aligned and everything is matching to the actual hardware. So the next step is where we are going to have a Python script developed to control this, and the third steps will be to have a simple Arduino program, and the fourth step will be where we are implementing Engine. So the second step is where we are creating a simple Python script. So I believe all of you know how to create a simple Python program is to add a Python program to your cell. So you have your program one here ready. So if you actually use the edit Python script, you have the inbuilt editor which is inside the RoboDK gets opened, but this is a very simple editor. So I don't know how comfortable you are usually generally editing on such kind of IDE. So I always suggest to use third-party IDs like PyCharm Community Edition or similar to that. I always use the PyCharm Community Editor, so this is what I generally use. So I try to develop my program inside this environment and then call inside the RoboDK work cell, or you can cut and paste this content into the Python program what you just created. It's all one and the same. So I would like to explain you the code on the PyCharm editor. So the first thing is using the RoboLink import function, which is the RoboDK API. So make sure that you always, if you're using it for the first time, make sure you add the library into your Python environment. I hope all of you know how to add a library. So, and then we are using two functions. One is the import serial function. This is to communicate with the Arduino. And the second one is that we are using some kind of time. So we are using the time library. So the first thing is we have to connect to the RoboDK. So the Python to connect with RoboDK is the RoboLink is a function. So RDK is equal to the RoboLink. That's a function we use. And then the second thing is our communication with the Arduino using a serial communication. So here I'm using a very basic hard-coded way of communicating on a serial way, which is specifying the communication port and the baud rate. So make sure that you check in your case what is the actual communication port and then the baud rate, what you actually use. So I'm using COM5 and 9600 as a baud rate. Then I'm just giving a bit of time today. And then the next critical thing is where you actually define your robot. So even the mechanism is named as robot. So robot is equal to rdk.item servo robot. So please go to your RoboDK file and ensure that this is the same. So here this is servo position. So what we are named is as servo positioner. So you need to also name your robot here. I just named that before as servo robot, so I'm just keeping it as servo position. So this is the name I have given. So it's not the name of the frame, but it's the name of your mechanism. Okay, don't name as this. This may be something different, but double click on this. It's the name, this name, servo positioner. That is the name which you have to ideally match it on your code. Now, once you're done that, then I've created a simple function where you actually specify the join number and the join target. So the join number is, suppose you have your position are multiple joins, you can tell what is the join number you have to you're trying to move, and then specify the target value, which is nothing in degrees. So here I'm using a function from the RoboDK Python API, which is actually listing the joins. So joins is equal to robot joins is listed, and I'm just printing it out. This is just for your clarity to understand what are the joins available and what are the values. So if in our case we do have only one joint, so this will only list one join. You can see here, this is the result of my previous execution. So you can see here the first value listed over here. This gives you the value of your first joint at the time I was executing. So that is the only one join, and that value was 0.0. And then I'm telling the joins is equal to the joins number. So here you make sure that if you're just hard coding it directly, you have to give the numbers which is corresponding to your join. So the first join will be 0, and the second join will be 1, and so on and so forth. So if I'm giving in a hard-coded way, it's just this. So join 0, it indicates the join number 1 in our case. But I'm just referring that to the value which I'm passing through this function, which is above, which is the join number. So I'm just copying back that. I'm just giving it join number, and that is nothing but that join number has to go to a specific target. So I'm giving the target. So the target is also passed here. So if you're just hard coding it, you can directly specify the value of your target. You have to move to 90 degree. You can always specify here 90 degrees. Okay, or if you move to 180 degree, which is the maximum in our case, you can also specify that. But I'm just passing it through this function, so I'm just using the join target here. Now, then I'm telling the robot.move. I'm using the join interpolation, so I'm telling it to move to that join. So in the joins, I already specified what is the number and what is the target. So the robot has to move to that specific. Robot has to move that specific join into that specific target what you gave. Now I'm also printing that what is the next, what is the resulted values, and at the same time I need to also communicate with the Arduino. So I'm using a function on the serial. I already defined the serial communication above here. Now I'm just passing a servo angle command. The servo angle is nothing but the join number, and I'm rewriting that servo.write as a string into servo underscore angle, and using the encode function I can pass it to pass the string into an integer which my Arduino code is expecting. So I'll explain you the Arduino code in the next step. And then we are waiting for the robot to move to that position, so that this is simply to make sure that the RoboDK simulation robot as well as your Arduino robot moves to the position. So this will only wait for the simulation robot, but we are just giving a slight delay for the hardware also to execute function. Okay, so that's a basic function. Once you have the function, you can see I'm just using that function. I'm just telling servo underscore join mode, which is my function. I'm specifying the join number and the target value. So in our case, I've done to the 0, which is the corresponding join number. I'm making it to move to 90 degree, 170 degree, and back to 0 degree. Okay, and I'm just closing the serial connection. So that's what I've done using the Python code. Now let us move to the next step, where how to create a simple Arduino program, so that we are clear how this value or this function is connected to that. In the Arduino, I'm using servo.h library, which is a standard servo library, and I'm configuring the serial connection. So the setup, what I'm doing is I'm just configuring the serial connection. So make sure that the baud rate what you put over here is the same as you use in the RoboDK environment. I'm attaching pin number 9 as the servo 1, and I am specifying the angle, which is nothing the value what I'm going to receive from RoboDK environment as 0, because the initial start time I just want to make sure that my axis is at 0, and I'm just writing it to the servo to go to that specific 0 degrees. Now in the loop, what I'm doing is I'm just waiting for the serial to be available, and I'm just waiting for the angle as an integer, and once the angle is received, I'm just writing it to the control servo function, which is going to write into that specific servo motor and move the motor to the, or control the motor to the specific angle you are commanding. So that's a very simple function. You can also use any kind of simple functions. You don't have to really follow this, but you can have any function which actually receives that integer and pass into your servo motor to control it. So that becomes your the third step, where you are creating the Arduino program. So I have the Arduino everything ready. So the next step will be I'll be showing you the hardware what I made, and then we are going to transfer this program and trying to execute this and check the result of this. So now you can see on my screen the setup what I just told you, that what I fabricated to demonstrate you this same application. So I do have a simple servo positioner, which is same as the CAD. So it's basically a 3D printed servo positioner demo unit. This is the same CAD what I used in my RoboDK construction too. So you can see here, this is a construction which you would have just seen it on the CAD. It's the same thing. So it has a servo motor. So I'm using a built Proton 180 degree high speed version, and it's not, you can use any of the one. I had this available, so I'm using that, and then I'm using a servo hub to connect the faceplate. And yeah, it's basically on a frame, and this is the moving faceplate. I have an Arduino Uno, and it's connected using 3 wires from the servo motor, which is nothing but the 5 volt for the power, the signal, and the ground. So that's pretty the setup ready here. Now the next part is downloading this the code what we just made on the Arduino IDE. So I do have the code here ready, so make sure that you have so I have the Arduino Uno on my COM port 5. So I'm just downloading the sketch what we just explained before. Yeah, it's done. So our next step is going back to the RoboDK. So of course we have the RoboDK available here now. I have my axis kept on 0 degree. So just to notice yeah, so you can see here this is a 0 point, and also on my positioner you can see here this is a 0 point. I have the same marking just to demonstrate the motion very clearly. Now you can see here I'm just having this motion here. Yeah, it's good. Yeah, it's not moving because we are controlling it using the program. So I'm just closing this guy up. Now we have the servo X position ready, and you know that our program is in the PyCharm environment. So as I told you, one option is to save that on a PyCharm environment and then call inside this, or the second option will be you can just open up your normal editor, and you can then go to PyCharm and copy this and paste it over here. So the first thing is I will run it from the PyCharm editor. I can show you that as well as I can just copy this. So let us copy this so that becomes easy for you all to understand. So I'm just copying this, just putting it over here. So we have all your, so make sure that this is in COM5 and you have the specific value of 9600, which is the baud rate. Okay, so I do have that, and make sure that your robot is in the same name as item over here. So we have the servo position here, so we do have the same name here. Okay, so I'm just giving file save, and I'm just closing this guy up. Now you have the servo position ready here, we have the Python program ready here, and we have the setup ready to execute. Okay, so I'm now right click and I'm just running my Python script. You can see here moving to 90. Yes, the motor is moved. It's 170 degree, 170 on the hardware, back to 0. Back to 0. There is a slight delay between the hardware and software. Of course, you know that because of the communication. We are using a serial port, and that will be a slight delay on that. So it's a very basic code. I will run it again. So currently it is on 0 degree. So if you double click on the positioner, you can also watch for the access values getting modified here. So I'm going to right click. So hope all of you remember the values. So I'll just show you the Python editor once again. So we are moving the first joint, the first joint, that is only joint available now. We are moving to 90 degrees, then we are moving to 170 degree, and we are coming back to the 0 degree. Of course, we are starting from 0 degree, which we are coded in the Arduino. So I'm just closing this guy up and right click, run. So you can watch for here 90. You can also watch here 90. It's 170, 170, back to 0. Okay. Just executing it once again for you all. First is 90, 90 on the motor too. Yeah, 170 degree, 170 on the hardware, and back to 0, back to 0. So that's a simple example to show you